Hello and welcome back to another video. In this problem, we're told, if p is a polynomial, show that the limit as x approaches a of p of x is equal to p of a. So we have some polynomial p of x, and that is going to be of the form cn xn to the an plus cn minus 1 x, and sorry, it shouldn't be xn, it should just be x to the an minus 1, cn minus 2 x to the an minus 2, all the way down to c2 x squared plus c1 x plus c naught. Right, if this is confusing, what you just have to understand is that this is a polynomial where the largest exponent is arbitrary, and then we have all of these different exponents all the way down to no exponent, right, x to the 0, just a constant term at the end. And I wrote it in this way because any polynomial that you can think of can be written in this way, where you assign, let's say it goes up to x to the 10th, and that's the biggest power, then an would simply be 10. So we'd have x to the 10th with whatever coefficient is out front, plus x to the 8th, or x to the 7th, or whatever the next one is, with whatever coefficient, and so on. And so p of a is just cn a to the an, plus cn minus 1 a to the an minus 1, plus cn minus 2 a to the an minus 2, and so on, plus c2a squared plus c1a plus c naught. Right, and this is just this exact thing, but we plugged in a for x because we're looking at p at a, where a is just some number. And the limit as x approaches a of p of x, we can find simply by plugging in a to p, because we have here a function where there is no domain restrictions, there's no discontinuities, right? A polynomial is a continuous function. We know that this limit is equal to the value if we're plugging in a, right? So that is cn a to the an plus cn minus 1 a to the an minus 1 plus cn minus 2 a to the an minus 2, right? This method that we've been doing this whole chapter, where if we have a, if we're divided by 0, we have some other problem, then we have to do extra steps. But once we actually get to that step where we have no domain restrictions and we can just plug in, because the values as we approach this value of x being a are just p of a, the way we actually calculate the limit now, this limit is just p of a. And so this is a representation of the methods we've been doing this entire chapter.